rigidness, and how flexibilities, fail proof, all those things it's being discussed here. To start with, I will just briefly go through this, the titles, then we can dive into the book content. So first of all, the book advocates about on deploying the applications to Kubernetes. So the book advises to use the templating and the packaging methods. So when it comes to templating and packaging, it's going to be hem or customized, or whatever you do, and it could be different if you are dealing with different system. But most commonly, these are the two systems. Then the book also advocates injecting the configuration rather than configuring that upfront. So which means that the injection would happen at the runtime. So the the upside is, you can, for example, um, if you want to disable or enable tracing or anything like that, this is possible. And it talks about rescheduling events. This can be discussed when we are discussing inside the book. That can be done. What are the events, what it triggers, what it takes to trigger that event, and what are um, uh, the cascading events. All those things we'll be discussing. Then what kind of props, why there is a prop required. There are three props discussed here: aliveness, readiness, and startup prop. And a little bit about how to implement them, what is the importance of them. Then we'll be discussing pod resource request and limits, why it's for, and in the lack of that, what would happen. All those things we can discuss. Then application logs, why it is required, what kind of application logs available, structured, unstructured, why it is there, what is the purpose of that. And a little bit about contextual information, why contextual information is useful in logs, that we'll discuss. Then exposing metrics. So logs is for reactive purpose. For example, any problems at production, you will go into the log and check, and something that you will trace and you will fix it. For exposing metrics for futuristic purpose, something like proactive actions from your project side, you will keep on monitoring some stuff, and you'll act on it. There are different methods to export that. We can discuss in detail inside. And finally, the instrumentation part. This is something completely different from the logging and observability, what we've been discussing, the metrics. This is tracing. This is something like when we are dealing with the distributed system, we need a unique identifier or something like that, which needs to trace the calls across the cycle, that we'll be discussing. With that note, I will jump in now. Is there any questions or anything like that, or you want to add something?
I
I
think
think
we are good. Just keep this. If you can keep the single page in the screen sharing. If you go in the view, you can change the layout. Currently, it's saying two pages now. You can go and change
yeah,
single
I
page.
did.
Yeah. Okay, now it is good. Okay, so if you increase the font a bit, that would be helpful. Though we are on our screen, but if you increase the font size, that will also be helpful.
Zoom out. Okay, zoom in. Zoom in. Okay. Is that okay now?
One more maybe. Yeah, should be okay. Yeah, this is okay. Yeah. Okay.
Yeah. If I will even zoom in. Oh, this is actually taking far out. Okay,
Okay. Fine.
I'll keep it here.
Yeah.
If it's not really, it's straining, let me know. I will not bother to increase that further.
We are good. We are good. Continue. Yeah.
All right. Yeah. So the big pictures here is all about the chapter. It discusses the best practices on deploying, configuring, and managing the life cycle, and finally implementing the tracing logics. So from the start to end, as you look at, it starts with deploying the application, what is the best practice, and then it talks about the configuration, and then it talks about logging, which is a case when the application running, and we want to ensure that it's running properly, and in case of any issues we are fixing it quickly, that is required. And then finally they are touching the part for the observability, which is for, it could be for business analytics, and to manage resource better in future based on the analytics in Prometheus dashboard or anything similar. And finally they are also touching the tracing part. Tracing means it's when you deal with the multiple downstream and upstream, there are a lot of things talking together, right? We need something to trace, to chain it together. That's what it means. With that note, we'll okay, so here comes the packaging and templating. As you see in this code here, in a typical deployment YAML file, we would have some value here, right? Something like 3, 4, however we want the replicas. In this case, we have values.replica count. So this one allows us to replace this value, replace this placeholder with any value. For example, you have development environment, you have a staging environment, and finally production environment. So this would allow you to populate development value, dev value, staging value, and production value. That would happen. So which package or application does that? You can do that with customize, or in this book they advocate hem. The hem and templates, hem charts has the capability to do that. The values YAML file usually does that magic. So you would usually have the dev values, staging values, production values, and that values would have values for these replicas. So this will remove the effort, additional effort for you to create file yourself every time there is a need. And also consider, if it is going to be manual, how many files it would be. There will be a lot of file. So to avoid that manual effort, it is advised to use templating logics, especially hem. If it is a simple project, you can use customize. Yeah, but you can use anything. That's what this book also advocates. Thinking about the templating engine or wasting time is not that much a wise idea. Just choose anyone and just go ahead. Okay, see here, when I change to one page, this is a problem happening. It navigates into two page. I will cut this. Just a minute. I will rather do a scroll like this.
This is better actually. This is better, much better.
Yeah, so this will at least allow us to have, as you see, I don't know if anyone have noticed, it is skipping a page.
Okay, that I don't know.
Yeah. Um, so so we have discussed about the deployment and the templating, about the templating, how the templating helps here, and the packaging application. Yeah, the packaging method that this book recommends is hem. Yeah. The next comes on managing the configuration. The configuration is recommended to be injected rather than to be bundled into image. This will allow easy change of configuration as required. Also, it allows to inject them at runtime. This will be more useful in terms of securing your application when you're dealing with sensitive application, sensitive information, passwords. This will be very useful in terms of security also. So it's both user friendly and secure. Also, this would enable to fetch this config map or secrets from something called vault. This will this loosely coupled, we call it as loosely coupled here. So that will allow to operate by itself, because it is decoupled here. It can interact with other element also independently and without disturbing the primary component. It will fetch its value from somewhere, which is more secure than storing as a plain text. And this example of how the config file look like. As you see, this talks about a debug files. This is a generic debug. One example I can recall is the config map where we have used is enabling Cilium audits. So the Cilium audit related policy and everything sits on as another YAML file, but for enabling the Cilium audit can be injected into a config map. Once we injected that to be true, from that time onwards, it will be recording the audits. It will monitor what is coming in, what is going out. So that's a simple use case I can recall.
Yeah, for secrets, anybody has seen using this dynamic secrets? I believe Vault would help us there, right? So anybody has good use case around dynamic secrets with vaults and anything like that?
Yeah, that would be great if have anyone have involved with fetching the secrets from vault, can share the thoughts here always.
Yeah, I mean, Vault is good, but it becomes an overkill maintain the Vault setup itself, right? Uh, because if Vault is down, your deployments get screwed. We've had good experience with tools like external secrets, which
Mm.
kind of hook into your cloud provider's secret manager. So, for example, in AWS, there is AWS Secret Manager, which is like a managed vault of sorts,
Mm.
right? Again, there are some considerations that you have to keep in mind. If you use too many secrets, then the billing is too high with AWS. So if you go with, let's say, one secret and maintain a JSON of sorts, and then your application can have the logic to kind of decode from that. That really helps saving cost. But then you have to find the balance, right? Because you have to keep on polling. The external secrets would keep on polling your secrets manager, and based on that, it would update your. And then you also have to handle the application reload logic there, right? Whenever the secret is updated, you have
Mm.
to reload your application. I guess even in case of Vault, if you update a secret, uh, I'm not sure if there's a native integration yet. The application still is unaware that the secrets have changed, right? You have to be careful about that.
So are you saying that for even having secrets managed by AWS, you
Mm.
need to pay per secret or per secret fetch?
Per secret, per request.
Okay, is it? Okay. That's very
Yeah,
interesting.
yeah, it is. It is.
Okay. No wonder how AWS makes money. So I think it's similar for other cloud providers as well, is it?
I'm sure. I'm sure. Must be
Okay.
similar.
Okay.
But things are changing with respect to these crazy costs, right? So recently, I read a blog article where Google now will not charge for the data transfer if you are moving out of Google,
Mm-hmm.
right? So let's say from GCP you decide to move to AWS or Azure or in-house or
Mm-hmm.
wherever, right? More often than not, you have a lot of data which has been collected over the years, and
Correct.
that one-time activity of moving everything out, right,
Uh-huh.
is a deadly cost. So now
Right.
they've come clean and said, it's free of cost. If you want to go, we won't be a blocker.
Yeah, of course. I
So
mean, if you're kind of putting your application on the cloud and if you're even database or whatever, let's say whatever S3 files, whatever is there, and if everything gets charged, it's going to be.
exactly, yeah.
Yeah.
So yeah,
Correct.
things are changing.
Yeah, and I believe would have be following that some company, right? That they keep publishing the blogs about how to move out of the cloud and all that stuff. Right? Anyway,
Are
that's
you
a
talking about
distraction.
Basecamp?
Something like not Basecamp. There's one more, maybe Basecamp.
Yeah,
They recently moved to data center, right? The
Yeah.
Ruby on Rails guy, David Heinemeier Hansen.
Ah, right. Correct.
Yeah, he's pretty vocal on Twitter. Like he's very radical as well.
Correct.
Mm,
Okay. Anyway, some other time. Let's continue.
sure.
Yeah, David is a great person. I'm also following him closely. Mm, yeah. Coming back here, so the book advocates that the best way to mount use the config is from your mount volume mounts. So this example says the mount path and the config name and how it's getting injected here. So this is how the config map and secrets can be injected.
Sorry, I just want to yeah, just pick up, ask you about to verify the solution. For example, with Secret Manager that I have to kind of integrate with because we can use any like operators for that, like and what I did, I just want to check on you if this is a viable solution because I kind of have doubts about it. That for example, the way we integrate it with a secret is with an init container that has a Python script that integrates with SDKs that gets the secrets, decrypts it, and injects it as an environment variable into the path. Well, first it mounts it on the empty dir so it can share the volume with the main container, and then as a in the main container, it being injected into the config file of this like a temporal framework distribute that we are running that needs, for example, database password. So that's kind of one solution. That's kind of in-house solution that Kyler was working on. I don't know. Do you think it's a good idea, or is it something that is somebody done or had experience with?
Yes, it sounds like a good idea, but so are your secrets stored in AWS Secrets Manager and init
No,
container?
the OCI. I'm in the Oracle Cloud, so it's OCI Vault.
Okay, okay. Because if I think of it in AWS or Google World, in that case, my init container should have the privileges to talk to the secret service. So what that would mean that every application, right, will need that privilege or permission or access to talk to your secrets service. But if you use something like an external secrets operator, uh, only your external secrets component has access to your secret manager, and it makes the secrets available for your applications locally on the cluster, right? So from security point of view, I think that's a slightly safer approach because you reduce the surface area. Rather than giving access to all your applications, there's just one app running with that access. And in case you have to rotate the keys or something like that, you just need to focus on one component rather than all the apps.
Yeah, in my case, it's different because we're using SDKs to do that. Since I don't think you have that operator that you're talking, or the approach that AWS has that restricts the access for the vault.
Mhm.
So in my case, I just using the SDKs to get the secret
Where
and
are the secrets stored?
vault,
So it is like
OCI
similar
vault.
to Spring Boot applications, right? I think they also have something similar, right? In those kind of applications, also you have SDKs to connect to your endpoints and get it. So yeah, I think it's a decent enough approach, Voldemar. That's what I can say.
Yeah.
I
This
have seen it
external
in action.
secrets operator also has integration with Vault, so it's worth taking a look. But yeah, I mean, as Nipendra also said, right, this init container approach is a decent enough approach, and that's how things have been done.
Mm.
Uh,
And one more thing.
Yeah,
Go ahead, go ahead.
the problem is I can use external secret operator because we are running an internal platform, and it's not usually possible to bring like open source tools like
oh, then
external
then that's
secret
a different
operator.
story altogether. Yeah.
Yeah,
Yeah.
yeah.
Other
Okay.
point what you mentioned about this, right? About access, right? You were mentioning about that the application need to have access to the AWS uh, external service, right, or whatever it is there, right? But I think
Yes.
one more way to do it is, I think we discussed this earlier that if we have um the node level access, right? So, for example, we know that a pod is running on a given node, right? And if that node has access to the external service, then work out, right? I think that whatever
But
that,
it's still not secure, right? That would also mean that all the applications running on that node
ha,
have
correct,
that
yes,
access.
right, that's true.
right?
Yeah.
So if even one of your application is compromised,
Hmm.
things can be accessed. Everything can be accessed.
But then also, I mean, that's a valid point what you mentioned. But even with the last AWS reinvent announcement, right? They have
Hmm.
bring in something per pod based authorization as well. So I think with that it would work out. I mean, so that if we somehow enable that pod based authorization, uh,
Yes. So here, yeah, I get your point. So I guess you're talking about IRSA, right? So IAM roles over service account. So you attach a service account with a pod, and that service account is linked with an IAM role, and that role has a limited access, right? So that's how that fine-grained control happens.
mhm,
But imagine that instead of giving that access to 50 different applications, right,
mhm,
individually, you just manage that access for one external secrets operator,
mhm,
right? So instead of giving access to 50 pods, irrespective of it is fine-grained or not, you just give it to one operator, which is not going to be exposed to public anyways, right? It's
mhm,
not a public service. Whereas your applications might be public, right? Your APIs might be public.
mhm.
So in that case, I mean, it's just a layer of redundancy that you add in security, right? I mean, there's no way that is 100% secure, but uh, yeah, it's just trying to reduce the surface area, as I said.
Okay, okay,
So,
understood.
Yeah.
so it's possible, like that's a good idea. It's possible to give a service account the permissions, for example, just a init container that will
Hmm.
start and get the secret, but the main container would not have that permission, and that will make more
No, no, I
secure.
don't think it's pod level, right? So
Yes, pod level.
It's pod
pod,
level. Yeah, okay.
yeah,
We can do the serious. Okay.
yeah,
So it all the containers have to have that. Okay.
yes. Yeah.
Great, good conversation. Okay, shall we resume to next topic here?
Yeah, yeah, please go ahead. You lead the session. Sorry, just
Yeah,
whenever you
it's fine.
want to come back on this.
It's
Yeah.
fine. That's the purpose, right? That's fine. So, as well as the practical difficulties being discussed and the solution discovered, this the purpose is met. That's fine. I'm happy for that. It's fine. So, the next context here is handling rescheduling the events. So, the nature of the Kubernetes is continuously the workloads is being distributed to different nodes continuously, right? So one, for example, one node can go off, and for that, the Kubernetes needs to react quickly and redistribute to other available pods. So in this particular topic, we are going to look at how this is happening, how the distribution is happening, what kind of signal is required to get that done. So the Kubernetes will send a SIG term when there is something to be terminated, which will kick off the cycle, and this diagram will talk nicely. So, for example, if user in this example they have simplified this user, could be anything to delete the pod. For example, if you plug out the node, everything gone, and at that time the Kubernetes will find a different node and reschedule. That will be a different signal. For this purpose, a user supplies the command Kubernetes kubectl delete pod. Then there will be another signal sent to the container on notifying the termination. So this will allow for a graceful shutdown. So graceful shutdown would not happen by itself. You'll need to mention for that. You'll need to provide configuration for soft eviction. We had spoke about that last week as well. So when you have given a configuration for soft eviction based on the grace period, the container will request for a grace period waiting time, and the API server will wait for that particular time. Then, if it is not responding properly or shut down, honor the time and shut down properly within the time limit, it will straight away send a SIG kill. So that will be deleted and recovered. So where this will be useful, for example, when you have a horizontal pod horizontal scaling, and you have scaled, and now you have multiple nodes, and you want to shrink it, and one of the node is actually having one pod or two pod, and it's still running the node, and you'll need to recollect that resources. That kind of situation where you will be using these signals. And this code snippet talks about how to include that graceful shutdown signal tracing, and also how to take the signal and process it. For example, just before I was talking about the container has to handle, the container itself will not handle these kind of signals. Within the container, your code will need to be capable to handle that signal. The Kubernetes job is to provide the signal SIG term, and any instance it needs to happen. Then your code, it could be Java or whatever, the library will receive the signal, then it will process and notify your internal system and stop processing further HTTP, so that your user might request something to this pod, and this the code running in the inside the container will stop accepting any new request. That way, it will prepare for its shutdown, and hence it can honor the grace period and shut down properly. So this code snippet just talks about a Go example on how to implement just that. This is a channel which is mentioning this initiation of the signal, and this one is mentioning the type of signal. It's interruption, and the signal name is SIG term. SIG term means a signal termination. So then there will be conditional blocks, and it will verify the case, and just shut down the HTTP server within the code, so that your code is not crashed because of this termination, and the resource also will be regained as expected. And this one is important. So the Kubernetes have a leverage of distributing the pod. However, it like that makes sometime not in favor of how we want to distribute the pods. So to avoid that problem, we can mention the pod anti-affinity, which means that at any given moment we don't want same type of pod to be scheduled on the same zone or similar to that kind of setting. We can mention this with the configuration podarity affinity, and as you see here, it says topology key zone, which means that your replication will not happen in same zone. It will be distributed across multi-zone, so you will get the fault tolerance to the level you expect. If any failure of a single zone will not take away two of your pod together, but only one of your pod. um, there is a caveat in this type of distribution. Even it says per zone it will distribute the pod. It might not evenly distribute. For example, in one zone it will distribute one pod, and in one another zone it will distribute a two pod or three pod or even five pod. So the difference could be multifold. To restrict that, there is another constraint. These are the constraint, just like we have it in SQL Server. These are the constraint. This is one you can consider. This constraint is little bit advancement of this one. Pod anti-affinity is lesser than topology spread constraint. So it's much better than the earlier one, which ensures that at any given moment, the difference of pod distribution is one. For example, one pod has two pods distributed of same type, and another pod might have three, and another pod might have one. So you can see at any given moment you have only one pod has a two, one pod has three, and one pod has one. So it is plus or minus one. So it's a difference. The max q could be one. So that is the constraint it pushes. I think I am telling it wrong. At any given moment it should be two, isn't it? One pod it could be one could be, it could be two, or one or two. So if it is a three distribution, distributed as three pods, it could be two or it could be three. Yeah, it's a one less. Maximum one difference can be there. So that is a constraint it pushes. Then
Yeah. So, anybody has used any of these things in production, like pre-stop hook and this topology stuff? Anybody has used in production? I definitely have used this pre-stop hook earlier, but not the topology one. I have not, at least for whatever done for myself and my customer, I have not seen that.
yeah,
But yeah, it seems useful. But anybody just want to see if anybody has done that. Yeah, it's okay if not, that's okay. But yeah,
yeah, it's rarely used, but yeah, that's a best practice. When you have a tight constraint should be for pushed multi-zone operations. I hardly seen such an environment, but yeah, when you have such a constraint you can take this. Then comes a typical prob. This would be useful, I think, for many of us. There are different types of probe where you can check the status of the container and its a state. So as you see, execs everyone have aware of. Within the Kubernetes, the command line we can supply exe, and if it is a non-zero exit, then which means that the container is unhealthy. um, yeah, if it is a zero it's a healthy. And similarly it has a http http probe also. As you are aware of lz, health is http your container port, and slash lz would give 200 usually. That is considered to be healthy one. The final one is if the kubelet is able to just make a connection with your container, then it is declaring that the container is healthy, because it is able to handshake to the container. So these are the best practices advised on this probe section. So we'll talk about liveliness probe now. As we discussed earlier, this http deals with lz. You can see container created, and it will wait for 60 seconds. Then there will be probe, a request to container ip slash something port and slash lz. So as far as it is getting the signal from 200 from the container, it's okay. Otherwise it will wait for 10 minutes 10 seconds. This is a configuration you will do anyway, and a certain amount of time it is failed, then it will go for a restart. So this is a life cycle advised here. So you'll need to configure in a way that how long it can be, it should wait, and how many times per iteration, how long it will wait for. In this example 10 second, and how many times. If it fail for 10 times, then we will deem that the container is not healthy, and it should be restarted. So based on the configuration, the Kubernetes API server will do the restart operation by itself if you have configured. Also, this book advises that doesn't mean if you can when you do the liveliness, it doesn't mean that it needs to be done in dependency. For example, when your service makes a call to database, your prop should not check the health of server, the backend server. When you do that kind of check, it might result in false positive or false negative, which would, for example, when you are able to probe successfully the service itself and the database is not, you will need to restart. That's what your configuration says, and the Kubernetes will unnecessarily restart, and most probably it won't solve the problem. So this they call cascading failure. And readiness prop. So when the container is being created, it would take a little bit of time to get started. Beforehand, it is getting ready and getting started. You can't serve that with your request. So sending such a request will result in failure. So to avoid that, there needs to be a configuration again for here. So these configuration has to go in your config. uh, the the illustration here, it says that, so container created, you need to wait for some period, this is configurable, then request for ready. So it is different from this. These are the standard terms, healthy and ready. Then when you get 200, it's all good, you can send the traffic. Otherwise, you will have to configure how many times you can wait and how many failures you can tolerate. Then again, this will result in a restarting, or disable the traffic for now. Then if it continues, you will do a restart. So this readiness is to make sure that the pod you are serving is ready, ready for accepting the request. Unless you check this and prove that this is up and running, you will not allow the HTTP traffic to that. This is one-time prop, startup prop. When you create a container, it will take a little bit of time, and some of the application might be heavy. Example, if you use a .NET application, I'm not against .NET, but yeah, the .NET application you are taking is taking a little bit of time to warm up, and it has lots of dependencies to get it up and running. That kind of situations where you will need to have internal configuration which talks about how long you will wait. In this example, container created, then you will have some wait period here, then request, and if you straight away received 200, go for it. It will be declared as live and ready. Otherwise, it will wait for some period. In this example, it says that we'll need to wait 30 times, which means that it needs to tolerate 30 failure probe. Then if it is not responding even after 30 probe, we'll need to restart. As we saw, all this dealing with checking the probe, checking the container for its readiness. If it is not available, it's a result in restart of server, restart of container, sorry. Yeah, these two probe is different. Yes, and liveliness, this will be continuous even after the container is ready and up and running. Anytime this will be probed when serving traffic. But the startup probe is only one time. Once initialized and started to run, that's it. You will not require to do that again. So what is the difference? How we see that it's ready? One difference here. It says instead of healthy, it says slash catch slash healthy. So that's how we can differentiate. It is a startup probe. Okay.
I mean, this has a. I mean, we need to set up the liveness and ready nose probe in the right way. Otherwise, things can go really wrong.
Yeah.
Um, which I have seen a few times. And then I've also seen one time somebody was configuring the I believe the readiness probe based on some third part. No, I think liveness probe only for some external endpoint, which was not a good suggestion anyway, right? So all of these liveness probe and the readiness probe, ideally when we are kind of configuring for the local app itself. Like what I'm trying to convey is, let's say um, you have some load balancer endpoint, right? And you are checking the health of the kind of a say load balancer endpoint and performing something, right? What I'm trying to convey is, let's say you are having a liveness probe configuration, and instead of setting the liveness probe for local app itself, you say that okay, I'm checking the liveness endpoint of my load balancer, which is outside anyway, and then I'll perform something. So that was initial confusion, I believe, but I think people are now figured out that is not a right approach. But in the beginning, when this particular feature was launched, people have even went that far as well. So, but Readiness Pro, I believe, have can be used for third party. For example, let's say if you are using the WordPress application and you want to make yourself up only if the database is up and running, that is also one good use case of Readiness Pro, because you want to make the WordPress app running only when the database is available. Otherwise, it's going to fail anyway. So, so there's
Usually, those kind of checks, I prefer to put in the init container, checking your databases, checking
uh
third-party services. Because if your init container fails, your pod eventually does not come up anyways, right?
no, but that is okay.
Because
One,
if you add it to a probe,
hmm,
uh, it's constantly getting hit, right,
correct, correct.
for no reason,
Yeah, that is also true. It should not
right?
get constantly
Plus in an
failing.
init script, I can do some advanced level of checks as well, right? Maybe
Correct.
readiness probe is just an HTTP ping of sorts.
Hmm. Hmm.
So
Yeah,
yeah, I mean,
good point.
I would suggest init containers for folks who want to actually try to do this.
Yeah, yeah, that makes sense. That makes sense. That you do it in a container. Yeah, that's a good point.
Great. And book advises not to use the props for controllers, jobs, or anything alikes. So the general rule of thumb could be whatever that serves a request can be checked. For example, the HTTPS request can be checked against the prop so that we can make sure that it is healthy and serves ready for serving the HTTP request.
So there's a comment in chat. I'm not sure if I totally get it. So I guess Obino says startup probe like removing a shell in a container before it starts to avoid one running exec. Uh, I don't think you would use probes for that. I think what you would want to use is the privileges that you give to the pod, and maybe use a stripped down version of the Docker image or container image, which does not have those executables in the first place. I don't think probe is the right way to achieve this.
Okay. Yeah. Coming back here on the topic pod resource request and limits. This is really important when you are dealing with the multi-tenancy. Uh, you could be dealing with the SaaS offering to different client. For example, I will take a trivial example, Jira. Uh, Jira, you have when you create a user, uh, uh, you create your new account, you will have your own space. You can create your a document and everything. It's only for you. And for paid customers, there are a bit more offerings. So what they are doing is based on the namespace or and other separation. Um, what they are doing is they are trying to restrict your resources, how much resource you can access, because at the end of the day, everything going to be in server, and the pod is going to be a server. So there needs to be some limit. So that's what the this topic is talks about. What is the maximum limit? What is the minimum limit? So when it comes to resource request, it talks about I need this kind of this is a minimum amount of memory or minimum amount of CPU I would like to have to perform operation. So this is a spec you can provide as a part of resource request. And resource limit you can share as a maximum one. So you can't have everything in the node. It needs to have a boundary. When you call out for the minimum requirement, you also need to call out what is the maximum. As a rule of thumb, the both minimum and maximum would be same. For example, if I'm claiming for 200 MB memory for my pod, it needs to be the resource request needs to be 200 MB. Also the resource limit also 200 MB. So I can make sure that my minimum memory is guaranteed. I can't request, it's not I can't. So it's a best practice to mention the same value, but you are allowed to mention any maximum values based on your config. It will allow to the level uh, it is allowed the resource limit mentioned. For example, you can mention resource request as 200 MB and resource limit as 500 MB. So based on that, Kubernetes will allow the resources. If that range is violated, it will send a SIG term. Then if it is not honoring again, it will send SIG kill. That is where the reusage of signal comes here. This is where the eviction comes. When there is a problem, there will be eviction. So you can make it as a soft eviction by giving a grace period time. We have only 4 minutes. I will rush here. So
No, I
this
think we don't have to kind of finish the chapter in one sitting. That is okay. So, I mean, we don't have to kind of say that, okay, we have to finish one book in one sitting.
okay.
We can kind of take some time for the next time also if you're available.
Yeah, yeah.
That is one thing, and I think it's better if we take some time next week time only. One thing is, of course, we'll rush through it. That will not be a good idea. And second thing is, the next chapter is supply chain security. I think, which is a very kind of a say very interesting topic, and very much everybody would be interested to kind of dig deep into this software supply chain part, right? So one thing is, of course, we can go over this particular chapter, but if there is any other material which we should go along with it. So, of course, we are going through the book. That's perfectly fine to finish the book. But as this chapter is going to kind of affect each one of us, right, in a big way, right, because supply chain is something which is very critical. If you want to come up with some other reading material, that is also fine. So I pinged one earlier with Abdul, which I can share here as well, which is like I think first three chapters are available at that book for free. But maybe if in the next call, if all of us can kind of go back and try to look at this particular topic and which I'm kind of a bit more in detail that what we should cover in supply chain. So what I'm proposing that rather than covering just the content of this book, we can kind of go a bit more broad and cover which are the recent topics, because I believe supply chain what is in this book, which is few years old. Now things have changed, correct? So if you can kind of do a bit of a research and also do from my side, and if we can come up with a bit more reading material, and then while going with this chapter, if we can cover that as well, that may be helpful, because supply chain is something which everybody has to kind of on top of things, right? So that's what my suggestion is, but we can discuss more in the next topic. But yeah. Um, there was one question on the chat earlier. Rajesh, you want to take it? That does eviction not take into consideration of quality of service? Do you have any points to add in here?
No. You have anything to share?
I think it does, right? So, but Usually people don't set any value on its default. So if all the pods have the same value, then it eventually would not have any effect. So I guess in the last chapter, one of the topics that was covered in the book was about adding dummy workloads to your cluster, so that more nodes can be ready and provisioned, so that they can work, deploy your workloads. In that, what you do is you create a dummy pod uh, uh, with high values of requests for CPU and memory, so that more and more nodes are attached to the cluster, but the quality of service, the QoS factor, is set to -1. So in that case, whenever a new pod is requested, this particular dummy pod gets evicted, right? And the new pod takes its place. But I guess if all the pods have the same value, then eventually there's no effect. There's
Yeah.
no priority.
Yeah, very good point. Okay, so I think we are good for today. Any comments, guys? Any suggestions? Okay, then we'll continue with this chapter, and as I was proposing, if we can bring in much more topics which we can cover in supply chain, we can consider that and discuss in the next time. Yeah. Okay. Thank you, everyone. We'll see you soon.
Great.
Sure.
Thank you.
Thanks,
Thank,
Rajesh.
thank you,
Thanks a lot.
Rajesh.
Thanks, guys. Bye.
Thank you.
See you next.